All right, so we're going to run through the first page of our study guide. So it says classify the triangles by angles and sides. So first, by the angles in this one, I have one right angle, so I can call this a right triangle. And now by the sides, each side is a different length, so I'll call this one scalene. Next triangle, we've got a 53, and a 74. All of these angles are less than 90 degrees, so I can call this acute. And 2.6, 2.6, 7.2. Two of the sides are the same. I can call this isosceles. Number 3, 22, 22, and a 136. I'll call this one obtuse. One of the angles is over 90. Then we have a 4.3, 2.3, and a 2.3, so these two are the same, so isosceles. Remember, if all of the sides are the same, it would be equilateral, and all angles were the same, it would be equiangular. The next section says classify the triangle by the sides. Use the distance formula to justify your classification. So recall the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we'll show all the work in here. So AB. We have the square root of, so we're finding the length of every single side. So AB will get -3 minus -10, so plus 10 squared plus -1 minus 4 squared. So -3 plus 10 is 7. 7 squared is 49 plus -1 minus 4 is -5. -5 squared is 25. So this equals the square root of 74. I don't really have to make that a decimal. I could if I wanted to. In the directions it doesn't say I have to, I can just compare all three square roots. For BC, square root of -5 minus -3, so plus 3, and 11 minus -1, so plus 1 squared. -5 plus, forgot to cross that, plus 3 is -2, -2 squared is 4, plus 11 plus 1 is 12, 12 squared is 144. So I have the square root of 148. So I know it's not equilateral. Then we have AC, the last leg. So we'll have square root of -5 plus 10 squared plus 11 minus 4 squared. -5 plus 10 is 5. 5 squared is 25 plus 11 minus 4 is 7. 7 squared is 49. So this is the square root of 74. So because these two are the same length, this would be an isosceles triangle. We'll do the same process for 5 and 6. I encourage you to pause and try on your own. So for AB, got 1 minus -2, so 1 plus 2 squared plus 5 minus -1, so 5 plus 1 squared. So this is 3 squared, which is 9, plus 6 squared, which is 36. So this is square root of 45. BC, square root of -8 minus 1 squared plus -4 minus 5 squared. -8 minus 1 is -9. -9 squared is 81 plus -4 minus 5 is -9. -9 squared is 81. So this equals the square root of 162. And now for AC, square root of -8 minus -2 So negative 8 plus 2 squared plus negative 4 plus 1 squared. Negative 8 plus 2 is negative 6. Negative 6 squared is 36 plus negative 4 plus 1 is negative 3. Negative 3 squared is 9. So this is the square root of 45. So this one again is isosceles. Two of them are the same. Last one we'll practice here is our third triangle, finding the distance. We got AB. So 0 minus negative 7, so 0 plus 7 squared plus negative 4 minus 1 squared. So we have 49 plus 25. 49 plus 25 is square root of 74. BC, 2 minus 0 squared plus 3 minus negative 4, so 3 plus 4 squared. 2 minus 0 is 2, 2 squared is 4, plus 3 plus 4 is 7, 7 squared is 49. This equals square root of 53. Then we have AC, so 2 minus negative 7, so 2 plus 7 squared, plus 3 minus 1 squared. 2 plus 7 is 9, 9 squared is 81, plus 3 minus 1 is 2, 2 squared is 4. So this is square root of 85. None of these lengths are the same, so this would be considered a scalene triangle. If we got them all to be the same, we would call it equilateral. This next piece says sketch the following. So we want an acute scalene triangle. So acute means all the angles are less than 90. Acute scalene triangle would be something along the lines of this. Oops, there we go. Acute and scalene. And we want to draw a median on it. So median, what's important is that it cuts the leg in half. So we'll denote that that's the middle. And these are two equal sides. And from this median point or midpoint, it goes to the opposite vertex, like so. So we're not worried about the angle that it creates at all here. Okay. Number 8, we want a right isosceles triangle. So I'm going to make a right triangle. So here's my right angle. And isosceles means I want these two legs to be the same. So then I'll create my base here. And I want an angle bisector. So what I'm going to do is I'm going to come from any of these angles and I'm going to be cutting it in half. So if I cut this angle right in half, be something like that. And then I would denote on here that that is the perfect halfway point. Number 9. We want an obtuse scalene triangle. So one of the angles needs to be over 90 degrees. Looks like so. And scalene means one of the none of the sides should be the exact same. So maybe something like that. And we want a perpendicular bisector in here. So bisector means it's cutting this leg in half. So put that somewhere right in the middle. And perpendicular means it's going straight up from there. And we need our right angle. So this one is the one that does not touch one of the vertices. Number 10. An obtuse scalene triangle. So similar to what I just drew. Something like that. And we want to draw an altitude. So I can draw the altitude inside my triangle like so. if I'm considering this my base. If I'm considering this bottom here one my base, then I can drop this vertex straight down and extend this leg, and then I would have my altitude here. Okay, remember I'm only dropping one down and I'm extending a line. So I cannot meet these two out here and call that an altitude. Can't do that. Okay. Similarly, I could extend this leg and drop this one out here if I'm considering this my base. Okay, but probably just draw one on yours. Number 11, an equilateral triangle. We want to put a median on it. So let's do an equilateral triangle. We're going to draw a triangle and attempt to make all the sides look the same length. So just do your best. And we want to draw a median. Again, a median has to cut. I'm going to call this equilateral. I will put one mark on each one of these. Okay. If I want to draw a median, I'm going to say, okay, this is the midpoint. This side's congruent to this side. And from this median point, I go to my vertex on the other end. And the last one, we have an acute scalene triangle. So acute, so it's kind of like sevens. Something like this. All those are less than 90. None of the sides are exactly the same distance. We want to draw a perpendicular bisector on this. So on here, I'm going to draw the midpoint on this segment, denoting that it's cutting it right in half. And I'm going to go create my 90-degree box and go straight up from there, like so. Okay.